Dear friends, welcome to my channel. My name is Johannes. So in this tutorial session, I'm going to show some equilibrium equations with three-dimensional axis. Z component will be added. So I think we will solve many problems on this. So we will see using only one equilibrium equation and using equilibrium equation and vector approach. So once we complete 2D equilibrium, now we are just rushing to 3D equilibrium. So I think we have put learning objectives of this topic, and we are just answering these learning objectives one by one. Now we are in a three-dimensional axis. Now let us see examples on this one. So example 3.9, a balloon in equilibrium. So you have three cables are used to tether a balloon as shown. Determine the vertical force P exerted by the balloon at A, knowing that the tension in the cable AD 481. So you have 481 force which is given for AD. AD means from here to here. So this is the force already given. Now how do you compute AB and AC? So I think you have a balloon. So a balloon contains air. So the pressure is exerting in the upward direction. And then it is just attached to the ground, B, C, and D points. Now let us see the free body diagram first. So this is the free body diagram. So TAB, TAC, and TAD acting to the downward direction, which is to the ground. And this is P, which is the force which is exerted by the balloon inside. So I think how to maintain equilibrium. So once you have this is known, how do you compute AB and AC? So this is the free body diagram overall. Now let's go to solution. So solution, summation of force, net force is equal to the sum of all forces exerting on that cables. So you have FAB, FAC, FAD, and P as a vector again, you have equal to 0. So the forces applied at A are, these are the forces, where P is P times J, because it is acting to the J direction. So I think let me display. So you have Y positive, since it is in the Y direction, it is acting, and you have Z positive here, and X here you have. Then you should focus on the coordinate axis. Then you have coordinate already, just point O is this one, origin 0, 0, and point A is this one. It is just on the Y direction. So you have 5.6 height. This is Y coordinate. The rest, it is just 0. And coordinate of B, again, you go just in the backward direction of X. So you put negative, just negative 4.2. Negative 4.2 for B. For B, negative 4.2, which is X. And the rest will be, I think, 0, 0, 0, 0, 0, 0. Clear? 0, 0. And the coordinate of C, again, you have 2.4 in the X direction. It is going, this is X, 2.4 in the X direction. And 0, just 0 in Y direction. No Y, but 4.2 in the Y direction, in Z direction. And for coordinate of D, again, you have coordinate of D. It is going backward, Z. So you have negative 3.3, this coordinate. So once you put the coordinate, you should write the other parameters. Just you have to put according to these coordinates. According to these coordinates, you will put again just B is this coordinate. Then AB means B minus A. So you subtract B minus A, negative 4.2. Then negative 5.6 J. So this is AB vector. AC again, C minus A, you subtract from C to A. From C to A, you subtract, then you get this value. And AD again, similarly, D minus A. You subtract from D to A. You subtract. Then you get this one. Then you can have unit vector in the direction of the force direction. So you have TAB as a vector. You have magnitude of TAB multiplied by unit vector in the direction of AB. then you will have this one, AB magnitude, or say you have here, which is given, which is 7, just the square root of this. Then you get this result. And again, you go similarly for AC. You have magnitude of TAC multiplied by unit vector in the direction of AC. Similarly, you have this result. You multiply by TAC for these unit vectors. Then you have again TAD, similarly TAD magnitude times unit vector in the direction of AB. Then you get this result. So once you get this, then let us see solution. So the solution is, I think you can see here, summation of all forces equal to 0. Then you substitute all results above, TAB and TAC, TAD, etc. You substitute, then collect like terms. Collect like terms I. Then you will just collect J terms, J coefficient, and this is K coefficient from the above equations. Then you will equate just 0 coefficients, just equating to 0. This equate to 0 because the product or summation will be 0 if these are 0. So you will just put 3 equations. Then once you have these equations, then you can substitute just TAC or TAB instead of one of the variable. Then you will substitute in this equation. Since you have TAD is known, clear? TAD is known. From here you can find TAC. Then once you find TAC, then you can find P again, AB again, you can substitute. So let us see. Now, since substitute TAD 481 Newton, already known in equation 2 and 3, in this equation, and in this equation, if you substitute, then solving the results, it will give you TAC will be 430.26 Newton, and TAD will be 232.57 Newton. And P is in the upward direction because the balloon is exerting just in the upward direction, and the tension cables are just exerting to the ground, attached to the ground. So I think this is the result. Now let us see another example, 3D concurrent forces. So determine the tensions in cable AB, AC, and AD. So you will establish coordinate axis. So no coordinate axis given here. So as much as possible, try to select the simpler coordinate, arbitrary axis. Try to select. So in my case, let me select this coordinate axis, Z to the upward direction, and just Y to this direction. Since it is a sailing, so I select this is the center, then X to this direction. So once you establish arbitrary axis, then you can go to coordinates. Take out coordinate of A. This is A. If you have this is origin 0. This is 0. Then once you have 0 here coordinate, then you go down. Z negative 2.5. So you will see Z is negative 2.5. Again, for B, you go to B. B is this one. So B is to the backward direction of X axis. You see, X is this one. So to the backward direction. So you have negative 1.5 X coordinate. You see, X 1.5. Then, and Y again, you have Y just from this center, you go to the backward direction, to this direction, clear? To this direction, negative 0.5. Then Z will be 0. Then C coordinate will be this one. So you go to Y direction. So you go to Y direction, which is this one, 1.25 only. The rest 0, 0. And D, this is the D coordinate. So you have in the X direction, distance 2 meters. You go distance 2 meters. And you go to the backward direction of Y direction. This point is backward direction of Y axis. So you put negative 0.5. So once you just establish arbitrary axis and taking out the coordinates of each necessary point, then you go to just write each cable force in vector form and write the unit vector. So the unit vectors are just AB divided by AB magnitude. So AB means B minus A. So you subtract B minus A like this. like the previous one. Negative 1.5 minus 0 will be negative 1.5. Just negative 0.5 minus 0, you have this one. Then 0 minus of 2.5 will be 2.5. Then divide by its magnitude, then you get this result. This is the unit vector, is the direction of AB force. And in AC, which is the unit vector in the direction of AC divided by AC magnitude, then C minus A, you follow the same procedure from this coordinate, C minus A. You subtract C minus A, then you get, you divide by its magnitude, then you have unit vector in the direction of AC, then unit vector in the direction of AD again, D minus A. You subtract D minus A. Then you divide by its magnitude, then you get this result. Then once you have identified the unit vector, then you should calculate TAB, just force as a vector. All forces should be in vector. Then TAC, you have TAB magnitude times unit vector in the direction of AB. So you multiply this TAB for this unit vector, So after multiplication, you get this negative 0.507 times TAB, I, etc. Then TAC, again, the same. You multiply TAC magnitude because we are just going to calculate the magnitude of these tension forces. Then TAC times this unit vector, which is the second one, this one. And TAD, again, you multiply by unit vector, magnitude by unit vector, just this one. You multiply by TAD. Then I think the other, you have weight as a vector, you should write. So since it is going to the downward direction, negative Z, so negative 120 times this one. Since this is mass times gravity, will give you this Newton. Then once you have this, using equilibrium equation now, sigma fx is equal to 0. Take coefficients of I from the above equations. Then you have this result. Then from here you can find TAD instead of just in terms of the TAB, 0.8217. Then sigma fy, take coefficients of J from the above equations, force vectors. Just you will take coefficient of J, this one, equal to 0. Then equation 3 again, summation of force in Z direction, take coefficient of K from the above vector equations. Then you have third equation. Then by substitution in equation 2 and 3, which is equation 2 and 3, this one, you substitute TAD, you substitute. So after substitution, you get this expression. Again, you get this expression, equation 4 and 5. Then you can collect now TAB and TAB here. Then let us solve simultaneously. So we are substituting TAD in this equation. Then you have this result. Then finally, simplifying equation 4 and 5 and solving simultaneously or by substitution. Then you have this simultaneous equation. Then you can go again TAC, you can substitute by substitution or elimination. You can follow. So plug into TAC this value from here. Then you will find this equation, only TAB. So TAB can be solved. Now TAB will be 569.05. So once you find TAB, then TAC can be calculated from this equation. TAC will be 376.03 Newton, and TAD again, you substitute in the first equation 0.8217 TAB, then you have this result. So this is just using equilibrium equation we are computing, but if you have additional unknown reactions, you may not finalize using one equilibrium equation. You may just apply a cross product or moment will be used. So let us see such example. Example 3.11, 3D equilibrium and vector approach. So you have this vertical mast. It supports 4 kN force and is constrained by two fixed cables BC and BD and a ball and socket joint at A. So A is the ball and socket joint. Then calculate the tension T1 in BD and T2 in BC. Can this be solved by using only equilibrium equation? Let us see. In just the previous examples, just we wind up using equilibrium equation, sigma fx, sigma fy, sigma fz, etc. But here we will add vector approach, which is cross product. So r cross f will be used. So let us see. First, you have to put out the coordinates. Coordinates of A will be 0, 0. Coordinate of B means which is this one. Only just focus on the coordinate, the axis given. X, C in the upward direction, X to this direction, and positive Y to this direction. Then 0, 0, 10. Only 10. C again, you have C. C is this one to the backward of X, so you have negative 5. The rest 0, 0. You don't have. And coordinate of D will be 4 in the X direction, Y in this direction, and Z 2. 2 meter will go up. So these are the coordinates. So once you find out the coordinates, then you will follow free body diagram. So T2 is exerting to this direction up to C, and T1 is going to D. So once you put this free body diagram, then you will have position vector R T1 and T2 by default equal, which is 10 meter, 10K. Then you have again RF, just position vector from the axis of rotation to the line of action of the force, 4 kilonewton. You have RF. So you have to put out this RT1 and RT2 and RF. Let us see. Draw the free body diagram. Unit vectors for T1 and T2 and force vectors already we have put. Then you should write this as a vector first. What is any T1? Any BD? BD divided by BD magnitude. BD vector, which is from B to D, so D minus B. So D minus B. You subtract D minus B. Clear? So D minus B, 4 minus 0, 4. 4 minus 0 again, 4. 2 minus 10, negative 8. So be careful on this just vector. BD means D minus B. So from terminal point, you subtract initial point. So I think be careful. So this is just a unit vector, is the direction of T1. The same is true for this one, BC divided by BC magnitude. So C minus B, subtract, then you get this result. Then you proceed like that. Then T1 means TBD, which is T1 magnitude times unit vector is direction of BD. Then you multiply T1 for all unit vector for this. Clear? Then you get this result. Again, T2, similarly, TBC or T2 times unit vector is direction of BC. You get this result. You simply multiply by T2 for this unit vector. Then once you have force vector, you have to write all forces as a vector form. So F is just going to the negative 4J, which is the opposite of Y direction, and A as a vector you have to write. So summation of all these forces should be equal to 0, and summation of moments again we will see. So this is summation of all forces should be equal to 0. T1 as a vector plus T2 plus F vector plus A vector should be equal to 0. Then let us see, taking the sum of moments at equal to 0, then you have just RT1, then XT1, just cross T1, RT1 cross T1, RT2 cross T2, RF cross F. So let me tell you about this triangle. So consider this triangle just counterclockwise positive. I cross J will be positive K. J cross K will be positive I. Then K cross I will be positive J. So just you will consider like this. Then if it is opposite, then we make negative. So let us see. RT1 first 10K. You go 10K or negative 5 I. This is RT2. And RT1 is 10K or 4I plus 4J plus 2K. Then you just proceed to the line of action of the force. Then just cross product you can follow now. The cross product will be 10K times this one. So K cross I. Let us see. K cross I, positive J. You see, positive J. K cross I, counterclockwise. So it is 10 times this one, then 4.08 T1 J. Since J is the result, K again, K times J. K cross J. K cross J, negative I. You see, negative I. It is just in the backward direction, to this direction. So negative, you put then 10 times this one, you multiply T1. Then you get this result. Then finally, again, you just multiply here similarly, 10K cross this. So K cross I, again, K cross I, positive J, you put positive J, but you have negative here, you put negative. 10 cross K, K cross K will be 0. Then 5K cross J. So K cross J, K cross J will be negative I. So negative times negative will be positive. 5 times 4 will be 20. So you have just arrived at this solution. So once you put this one, then let us go to summation of moment in X is equal to 0. Take coefficients of I equal to 0. So coefficient of I will be this one and this coefficient of I. So you get this result. Then T1 can be this result. So this is the magnitude of tension T1 and the sigma moment in Y direction equal to 0. Take coefficient of J again. So T1 minus this equal to 0. Then you get this result. So you have, I think, you are forced to use this equation. Why? Because ball and socket joint, you have 3 unknown reactions: AX, AY, and AZ, and also T1 and T2. So I think just 5 unknown reactions you have, but we have equilibrium equation, summation of force in X, in Y, in Z, and the summation of moment. So you cannot finalize. That's why we are using this equation. So once you find the T1 and the T2, then you can find, just to find the force supported by the ball and the socket joint, you just sum up all force vectors equal to 0. Then a similar procedure, you go take coefficient of I, coefficient of J. So in the previous, we put T1 in the first, T2, F vector, and A vector. So once you know T1 and T2 from moment, from cross product, then you can collect like terms, sigma fx equal to 0, take coefficient of I from the above equation, then AX will be computed. There, AX will be computed. Take coefficient of I only. I here, you have I, then I here. Then you sum up, then equate to 0, then you get this. AX will be negative, so you assume positive X, but it will be reversed. So I think this is a diagram. So you can have X to this direction, reversed. So this is a free body diagram. Then sigma Fy will be take coefficient of J from the above equation again. Coefficient of J means this one plus coefficient of J, you follow coefficient of J, this one. You see, minus 4 equals 0. Already T1 known from the above moment equation. Then AY will be 2 kilonewton. According to our assumption, it is correct. AY will be just to the positive Y direction. And I think you have sigma Fz, take coefficient of K from the above equation. Again, you follow the same procedure. Az will be this one, negative. So you just assume Z to the positive direction first. You draw in the free body diagram. So this will be cancelled. Then you go down. This is just the result. So I hope this is all about today's tutorial. If you have any question, thanks for watching. If you have any question or doubt regarding these problems, please write down in the comment section below. I will reply on it. So thanks again.